Today, let us discuss application of derivatives under this section, increasing and decreasing functions. What is an increasing function? A function f of x is said to be a monotonically increasing function on an interval a comma b. For any x1 comma x2 belong to a comma b, we have that if x1 less than x2, then f of x1 less than f of x2. Monotonically increasing means strictly increasing function. The function is increasing if f dash of x greater than or equal to 0, and the function is monotonically increasing if f dash of x is strictly greater than 0. Similarly, what is a decreasing function? A function f of x is said to be monotonically decreasing function on an interval a comma b. For any x1 comma x2 belong to a comma b, we have that if x1 less than x2, then f of x1 greater than f of x2. Monotonically decreasing means strictly decreasing function. The function is decreasing if f dash of x is less than or equal to 0. The function is monotonically decreasing or strictly decreasing if f dash of x is less than 0. So based on this, we'll go for some problems. Show that the function f of x equal to x cube plus 10x plus 7 is strictly increasing for x belonging to R. That means x belongs to a set of real numbers. So we are given that f of x equal to x cube plus 10x plus 7. Differentiate with respect to x. F dash of x equal to 3x square plus 10. Here 3x square greater than or equal to 0 and x and 10 is greater than 0. Therefore, we get a 3x square plus 10 is strictly greater than 0. That implies f dash of x is greater than 0. Thus, f of x is strictly an increasing function. Test whether the function f of x equal to x cube plus 6x square plus 12x minus 5 is increasing or decreasing for all x belonging to R. We are given that f of x equal to x cube plus 6x square plus 12x minus 5. Differentiate with respect to x. F dash of x equal to 3x square plus 12x plus 12. 3 is common, then take 3 out. It gives you 3 times x square plus 4x plus 4. X square plus 4x plus 4 is nothing but x plus 2 the whole square. Therefore, we get f dash of x equal to 3 times x plus 2 the whole square. 3 times x plus 2 the whole square is always positive for x not equal to minus 2. To take any value other than x equal to minus 2, this expression will be always greater than 0. For x other than minus 2, keep it in mind. And 3 times x plus 2 whole square equal to 0 for x equal to minus 2. Therefore, f dash of x greater than or equal to 0 for x belongs to R. So thus what we get is f of x is an increasing function for all x belonging to set of real numbers. Find the values of x for which the function f of x equal to x cube plus 12x square plus 36x plus 6 is monotonically increasing and monotonically decreasing. We are given that f of x equal to x cube plus 12x square plus 36x plus 6. Differentiate with respect to x. This is the common procedure for all the problems of this kind. Differentiate f dash of x is equal to 3x square plus 24x plus 36. Again 3 is common here. 3 times x square plus 8x plus 12. So this is a factorizable expression. We can factorize it. So we get f dash of x equal to 3 times x plus 2 into x plus 6. F of x is monotonically increasing if f dash of x is greater than 0. That is 3 times x plus 2 into x plus 6 is greater than 0. Dividing both sides by 3, we get x plus 2 into x plus 6 greater than 0. So x plus 2 into x plus 6 is positive under two conditions. So then either x plus 2 is negative and x plus 6 is also negative, or x plus 2 is positive and x plus 6 is also positive. Let us take the first case, consider the first case. X plus 2 negative and x plus 6 also negative. That is x is less than minus 2 and x is less than minus 6. Then on the number line we can easily understand that so for all the values of x which are less than minus 6, f dash of x is positive. So whatever that is less than minus 6 is always less than minus 2 also. So both the conditions are satisfied by these values of x. Thus for every x less than minus 6, this is positive. X plus 2 into x plus 6 is greater than 0. Second case, what it says is x plus 2 positive and x plus 6 also positive. That is x greater than minus 2 and x greater than minus 6. Again on the number line we can note that any value of x which is greater than minus 2 is greater than minus 6 also, and hence the derivative f dash of x will be positive. That is for x greater than minus 2, x plus 2 into x plus 6 is greater than 0. Therefore from case 1 and 2, f of x is monotonically increasing if and only if x is less than minus 6 or x is less than greater than minus 2. Hence x belongs to the interval minus infinity to minus 6 or minus 2 to infinity. These two can be clubbed together in the form of union of two sets as x belongs to minus infinity comma minus 6 union minus 2 comma infinity. Next is f of x is monotonically decreasing. Monotonically decreasing means f dash of x is negative. So that is 3 times x plus 2 into x plus 6 is negative. Again that is x plus 2 into x plus 6 is negative. Here also we come across two cases. Then either x plus 2 greater than 0 and x plus 6 less than 0. That means one factor is positive and another factor is negative. Or x plus 2 is negative and x plus 6 is positive. So first case, x plus 2 greater than 0 and x plus 6 less than 0. That is x greater than minus 2 and x less than minus 6. Note it carefully. Check it. There is no value of x satisfying this case, because a number can be simultaneously greater than minus 2 as well as less than minus 6. This is not possible. Hence this case is not valid. Second case, x plus 2 less than 0 and x plus 6 greater than 0. That is x is less than minus 2 and x is greater than minus 6. That is x greater than, same thing is put in the reverse order, x greater than minus 6 and x less than minus 2. That is minus 6 less than x. X greater than minus 6 means minus x less than x, and x is less than minus 2. So this means minus 6 less than x less than minus 2. That is the x value lies in between minus 6 and 2. Minus 2, sorry. Minus 6 and minus 2. Thus for minus 6 less than x less than minus 2, we get x plus 2 into x plus 6 negative, less than 0. Therefore f of x is monotonically decreasing if minus 6 less than x less than minus 2, and that is put in the form of a set as x belong to open interval minus 2 comma minus 6. Show that the function f of x equal to 3x plus 1 upon 3x is increasing in 1 by 3 comma 1 and decreasing in 1 by 9 comma 1 by 3. We are given that f of x equal to 3x plus 1 upon 3x. Again differentiate with respect to x. That gives you f dash of x equal to 3 plus 1 by 3 times minus 1 upon x square. Derivative of x is 1. So this part becomes 3 into 1 as 3. 1 by 3 goes out. We get the derivative of 1 upon x. Derivative of 1 upon x is minus 1 upon x square. Therefore, we get f dash of x equal to 3 minus 1 upon 3x square. F of x is increasing if f dash of x is greater than or equal to 0 and decreasing if f dash of x is less than or equal to 0. This is the known condition. So let us consider the first part, that is x belongs to 1 by 3 comma 1. So now what is our aim is, we try to get derivative, this part, 3 minus 1 upon 3x square, using this interval. So this means 1 by 3 less than or equal to x less than 1. That means x lies in between 1 by 3 and 1. That is squaring throughout, we get 1 by 9 less than or equal to x square less than or equal to 1. See, observe the stages very carefully. I am trying to bring f dash of x here in this part. So first I got x square. Now I will make it as a 3x square. So multiplying throughout by 3, we get 1 by 3 less than or equal to 3x square less than or equal to 3. Now taking the reciprocal. When I take the reciprocal, it becomes 3 greater than or equal to 1 upon 3x square greater than or equal to 1 by 3. So note this step carefully, because this is very important thing. When you take the reciprocals, inequalities change. They turn to the reverse side. So less than or equal to becomes greater than or equal. And now multiply throughout by minus 1. Again note this step very carefully. So when I multiply throughout by minus 1, what happens is again the inequalities change. So greater than or equal to becomes less than or equal to. So, and also simultaneously note the steps or the method what we are doing. So we are trying to bring here f dash of x, 3 minus 1 upon 3x square. Now to get 3, what I should do is I have to add 3 throughout. So by adding 3 throughout, we get this 3 minus 3 less than or equal to 3 minus 1 upon 3x square less than or equal to 3 minus 1 upon 3. So this is actually f dash of x. So we get 0 less than or equal to 3 minus 1 upon 3x square less than or equal to 8 by 3. So f dash of x lies in between 0 and 8 by 3, that is 0 less than or equal to f dash of x less than or equal to 8 by 3. Therefore f dash of x is positive, greater than or equal to 0 rather, greater than or equal to 0 for every x belonging to the interval. So what it says is f dash of x is positive. 0 less than or equal to f dash of x means f dash of x is greater than or equal to 0. This is possible because of this interval what we started with. So f of x is increasing for every x belonging to 1 by 3 comma 1. This is the interval. Second part, at x belongs to 1 by 9 comma 1 by 3. Again we do the same process. So first let me put x in between these two. So then 1 by 9 less than or equal to x less than or equal to 1 by 3. Again squaring throughout. So we get 1 upon 81 less than or equal to x square less than or equal to 1 by 9. Now multiplying throughout by 3, because I want to get 3 minus 1 upon 3x square. First let me get 3x square here. So when I multiply throughout by 3, I get 1 by 27 less than or equal to 3x square less than or equal to 1 by 3. Now taking the reciprocal throughout. Again note this step very carefully, because when you take the reciprocal, these inequalities change. They reverse their direction. Again I multiply throughout by minus 1. So we get minus 27 less than or equal to minus 1 upon 3x square less than or equal to 3. Again the inequalities change their directions. Greater than or equal to has become less than or equal to. And what I want is 3 minus 1 upon 3x square. Again I add 3 throughout. So adding 3 throughout, 3 minus 27 less than or equal to 3 minus 1 upon 3x square less than or equal to 3 minus 3. So what we get is minus 24 less than or equal to 3 minus 1 upon 3x square less than or equal to 0. So again note, this is the derivative. This part is a derivative of f of x. So we get minus 24 less than or equal to f dash of x less than or equal to 0. That means f dash of x is less than 0, less than or equal to 0. So this is possible in the interval 1 by 9 comma 1 by 3. This is possible. Thus f of x is decreasing for every x belonging to 1 by 9 comma 1 by 3. Thank you.